In this video, we will discuss a very important application of eddy currents, and this is a magnetically leviated trains. This is also called as maglev. The maglev trains are basically having two types of suspension systems. The first one is electromagnetic suspension systems, which is EMS. So the diagram of this is shown that this is a guideway which is almost similar to track, and this train is connected to this track like that, and there are small wheels on this inner surface between this train and this guideway. So these wheels are responsible for initial acceleration or the final retardation of this train, and these are the magnets. This is guidance magnet, and this is support magnet, and this is stator. Now I will explain how does this electromagnetic suspension system works. Now the initial movement to the train is given by the wheels which are connected at this position. Small wheels which are connected in this position. Initially, they are responsible for the movement of the train. This guide magnet is responsible for the alignment of the train with the track, which means that the train should not go left or right. It should be aligned so that it may not be derailed, and therefore these guide magnets are connected with sensors which are maintaining a constant 25 gap between these. This gap is 25 So these guide magnets are responsible for alignment of this train with the guideway or track, and these magnets are responsible for the leviation and the propulsion. Now, what is leviation? Leviation means the train. Obviously, we know that maglev trains are moving in the at a gap from the track. They are not exactly moving on the track. They are moving in the air, and due to this property that they move in the air above the track by a distance of almost 150 This distance is almost 150 So this leviation means lifting up the train. So this leviation is 150 and this train has an advantage that due to the leviation, there is no friction involved, and therefore there is no loss of energy, as well as they can achieve a very high speed up to 1600 kilometers per hour. So how does it leviates and how does it propels? Now these magnets which are connected on this track, and this magnet is the magnet electromagnet which is connected to the guideway. So when this is the train part, this is the vehicle, and this part is connected with the vehicle, and this is the track guideway. So these magnets are connected with the vehicle, and this is connected with the guideway. So when these magnets are repelled with each other, because they are electromagnets, so there is a force generated which has a component which is vertically upward, which is in the vertically upward direction, as well as a component I'll show you that a component is acting in this direction, which is responsible to balance the mg of the train. So this is balancing the mg, and this is responsible for the leviation of train, and this component which is acting in this direction like that, this is responsible for the propulsion of train. So this component moves the train in the front direction, as well as this component leviates the train and this component propels. So this is the electromagnetic suspension. We will also discuss the second part of maglev trains, which is electrodynamic suspension or EDS suspensions. So it is based on superconductor technology. Let me first introduce you with superconductors. superconductors are those devices which have zero resistance, and therefore it is also called as superconductor. Now, for any material, if we cool it down below its critical temperature, then it would be entering the stage of superconductivity, and in that stage the resistance of that material becomes absolutely zero. Now, the thing which is the property which is very useful here is the property that this superconducting materials are perfect diamagnetic materials, and the diamagnetic materials does not allows the external magnetic field lines to pass through it. In fact, they are repelled through the external field lines. So this is a diagram, this is a picture in fact, which is representing that this superconducting material is floating in air. And why does it floating? Because this is a magnetic field, strong magnetic field, and this superconducting material is expelling this magnetic field, which means this material does not want that magnetic field lines should pass through it, and therefore it is going away from this magnetic field. So there is a force which is propelling this superconductor away from this magnetic field, and this force is balancing out its mg. So if any superconducting material is kept on a strong magnetic field region, then it would float like that. So this property is used in maglev trains in EDS suspensions. Now, first of all, I will tell you that unlike the electromagnetic suspension, these trains have huge superconducting magnets fixed on their sides. You can see that. So these are superconducting magnets. Superconducting magnets. Now these are the conducting coils which are arranged in the side of the track. So this is the walls of the track, and this is coils which are arranged in form of a 8. So you can see with the diagram that this south pole will attract this north, and a force will be generated like that on this north pole, and obviously this north pole is attached to the train, and therefore this force is acting on the train itself, and this north will repel this north, and this force will be generated. Therefore a resultant force will be generated in the upward direction. The components of these two forces are in the upward direction. Similarly, this south will repel this south pole, and and this north will attract this south pole. So the components, vertical component of both these forces is like that. So these two vertical components are lifting up this train, and these are balancing the mg of the train. So this is the leviation technology. Now I will illustrate the propulsion. You can see, first of all, I will tell you that these coils which are attached on the walls are having alternating currents. So this north and south is changing quite rapidly. Now you can see a situation that in this situation the poles you can see, and the forces direction you can see. Now I will demonstrate that this north this north is attracting this south, therefore a force will be generated like that on the train, and this south is repelling this south, therefore a force will be generated like that on the train. Similarly, this force is generated like this, and this is like. So you can see that the component of this force is in the direction of the movement of the train, and here also it is same. that this is attracted like that and this is being repelled like that. So the component of these forces I are acting like that. So this component is responsible for the propulsion or the movement of the train in the horizontal on the horizontal track in the forward direction. So this is the propulsion of the maglev train equipped with EDS suspension, and I've already explained the leviation in the previous screen. So this was the complete knowledge of the maglev trains, and these trains are the future of our world, and these are very important because I've already discussed that there is no loss of energy in these trains because there is no friction, and there is a probability of achieving a very high speeds which are almost equal to 1600 kilometers per hour because there is no involvement of friction, and there is no opposing force apart from air. Obviously we cannot neglect it. So this is the maglev.